enterprise billing systems face a severe operational bottleneck. Every single second, millions of asynchronous rating events flood into the server architecture. These events arrive from external sources, like SAP convergent charging or legacy rating engines. Each ping represents a raw unit of consumption, a completed phone call, an API request, or a gigabyte of data transfer. The architectural challenge is absolute accuracy at massive scale. The system has to ingest this uncoordinated data and translate it into mathematically perfect, structured financial accounting documents. If the database locks up or drops a packet, revenue is permanently lost. To survive this volume, the billing engine cannot process events reactively. It requires a highly structured, predetermined payload to dictate the exact workflow from the very moment of impact. This is the foundational unit of SAP convergent invoicing, the billable item, or bit. The bit functions as the active, executable input that drives every downstream step of the billing and invoicing process. To prevent data collisions, the database strictly segregates these items based on their processing status. A newly ingested item receives a status of 0, marking it as raw, while a successfully processed item moves to status 4, indicating it is billed. By continuously sorting items into these isolated status buckets, the system can process tens of millions of records concurrently without losing track of a single cent. A billable item's trajectory is dictated by 3 metadata elements. First, the billable item class defines required technical fields. Next, the billable item type specifies business significance, distinguishing recurring from one-time fees. Finally, the billing subprocess creates an independent track to segregate unrelated items. Without these 3 specific classifications, a bit cannot be routed, grouped, or billed. They form the operational DNA of the transaction. Below the external routing metadata lies the internal payload of the bit itself. This payload is divided into distinct structures known as record types. The mandatory anchor is the main item, designated as record type IT. This holds the fundamental financial data required for billing. Attached to the main item are dependent record types. Record type PY contains payment data, record type TX stores tax calculations, and type TT holds text descriptions. These dependent records are physically stored in separate database tables to optimize memory management. The system cannot process them if the parent IT record is missing. A bit operates as a highly protected, self-contained financial ecosystem. Its metadata tells the system where to go, while its internal record types prove exactly what the transaction is worth. This diagram illustrates the core engine of SAP convergent invoicing, the billing process funnel. This engine operates in 3 strict sequential phases: selection, grouping, and aggregation. To observe how this manages diverse streams, let's trace the data of Telecom 1. On the left, Stream A handles massive volumes of rapid micro-usage charges. On the right, Stream B handles fewer recurring monthly fees. How does a singular billing engine process these radically different streams concurrently without accidentally inserting a microscopic data usage fee into an internet sales invoice? Phase 1 is selection. The billing process first queries the database to identify specific contract accounts scheduled for billing. At the funnel's top, the selection variant acts as a strict gatekeeper, scanning the metadata of all incoming billable items. Because Stream A and Stream B were assigned to completely different subprocesses upon creation, the selection variant can selectively pull the micro-usage charges for processing while entirely ignoring the internet sales during this specific run. These subprocesses function as invisible walls, ensuring that mathematically incompatible business lines never intersect in the active database memory. Items that pass the selection filter drop into Phase 2, grouping. Here, the system bundles individual items together into distinct clusters known as billing units. The system enforces an immutable rule. To enter the same billing unit, items must share the exact same contract account, business partner, and subprocess. Administrators can apply custom grouping variants to enforce even stricter splits, forcing items into separate units if they rely on different currencies or span different billing periods. Grouping takes a chaotic list of isolated rating events and organizes them into a highly targeted, customer-specific payload, ready for final financial summarization. The final step is Phase 3, aggregation. This is the exact moment where raw billable items are permanently translated into finalized billing document items. For Stream B's internet sales, the system uses a one-to-one mapping relationship. One billable item representing a monthly fee directly equals one discrete invoice line item. Stream A requires a different approach to handle the crushing volume of millions of microtransactions. It executes an end-to-one mapping. Thousands of tiny usage charges are mathematically merged into a single, dense, summarized base item. The default aggregation logic is exact. The system only merges these items if all relevant fields match perfectly, like the billable item date or the specific charge key. Aggregation acts as the ultimate defense mechanism of convergent invoicing. It preserves absolute granular financial accuracy while protecting the downstream invoicing database from being overwhelmed by microscopic line items. As the grouped and aggregated units drop out of the funnel, the system instantly generates a formalized billing document. This diagram shows the dual table architecture. The top-level header data, stored in table DFKKKINVBIL_H, locks in execution dates, partner IDs, and status. Beneath that, the line items, stored in the _I table, hold the summarized financial weight, exact quantities, and transaction tax. While a single contract account can generate multiple billing units during a run, each individual unit results in exactly one immutable billing document. Because of this structured aggregation, the system maintains a critical audit capability, traceability. An IT auditor can select a highly summarized line item in a finalized billing document and trace it backward to reveal the thousands of original source items that built it. As the billing document is successfully written to the database, the system executes one final action. It updates those original, raw, billable items to status 4, marking them as billed. Pushing an item to status 4 permanently removes it from the active billing queue, physically ensuring that a single transaction can never be billed twice. A flawless, auditable invoice is never built at the end of the pipeline. Its perfect structure is predetermined by the class, subprocess, and type assigned to the data at the exact millisecond of ingestion.